Hey guys! Alright, now we're going to do section 2. So chapter 7 section 2 is called Addition Counting Principles. So basically we're going to be using the addition counting principle, and we're also going to be talking about unions and intersections and complementary events. So the first vocab we have is a union and an intersection. So hopefully you learned this already when you talked about set theory before, but if not, we're just going to talk about it again real quick. So union, the way that we write that is with this symbol, which to me looks like a U. Okay, so that's called the union of A and B. Okay, that stands for all the elements that are either in A or in B. Okay, so basically they're in A, they're in B, or they're in both, doesn't matter. It's everything all united together. The way I like to think about it is if you were to get married, okay, you now have a union of two families. So that person's family that you just married is now your family. So you're taking those elements from your family, you're taking those elements from your husband's family or your wife's family, okay, and those are all coming together into a union. Now they're part of your family, okay, so the whole thing is your family now. All right, we also have intersection. So the way we write intersection is with this upside down U type of thing. Okay, and that's all elements that are both in A and B. So they have to be in both sets in order to be part of that intersection. So the way I like to think about an intersection is like an intersection in the road. You've got two roads that are crossing, and if I say I'm on the intersection of First Avenue and A Avenue, okay, that means that I'm on both roads. Okay, so I have to be part of both roads in order to be on that intersection. Or another way you might think about it is when we talk about intersecting lines, we know that those lines intersect at one point, and that point is called the intersection because it's on both lines. All right, our next vocab word is called disjoint or mutually exclusive. Okay, so if you're mutually exclusive, that means that you don't have any elements in common with another set. So for example, if I have my A equals 1, 2, 3, and my B equals 5, 6, okay, these sets would be disjoint or mutually exclusive because they don't have any elements in common. All right, when sets are mutually exclusive, we can say that the number of elements in the union is equal to the number of elements in A plus the number of elements in B. And we can say that the probability of the union is the probability of A plus the probability of B. So the way I write that is the number of elements in the union of A and B is equal to the number of elements in A plus the number of elements in B. Or I can say the probability of A union B is equal to the probability of A plus the probability of B. And remember that these are only true when you have mutually exclusive sets. Okay, those are not true if you have an element in common. If you have an element in common, then you have to take some stuff out. Okay, so our first question says, if two fair dice are tossed, what is the probability that the sum is either 2 or 3? So if we look in our book on page 427, there is a dice chart under the example 1. I'm going to give you guys a paper copy of this dice chart that you can use on all the quizzes and tests, but for now we'll just look at the one in the book. So basically we've got all these different die, and I have two different colored die because again we need to think about order. So you could get a 1 and a 6, or you could get a 6 and a 1, and it does change because they are different events. Okay, so it's saying if two fair dice are tossed, what's the probability that the sum is 2 or 3? If you look at this dice chart here, okay, getting a sum of 2, well, there's only one way you can do that, and that's if you have a 1 and a 1. Okay, so there's one way that I can get a sum of 2. Okay, if I want to get a sum of 3, well, there are a few ways that I can get a sum of 3. I could either have a 1 and a 2, or I could have a 2 and a 1. Okay, and you'll see that the total amount of events that I could have by rolling 2 die is going to be 36 events. So there's 36 possible outcomes. So I've got 3 out of the 36 possible outcomes that could occur, and notice that these 2 sets, a sum of 2 and a sum of 3, are mutually exclusive, meaning they don't have anything in common. Therefore, I can just say that the probability of the union is going to be the probability of A plus the probability of B. So this is going to be 1 out of 36. This is going to be 2 out of 36. If I add those together, I get a probability of 3 out of 36 for getting either a sum of 2 or a sum of 3. Alright, the next problem is using the addition counting principle, which says that sets may or may not be mutually exclusive. Therefore, we can use these 2 different formulas where we subtract out the intersection in order to find the probability of the union. Now this is the formula that I would probably just memorize if I were you. I wouldn't really worry about that other formula, because if your sets are mutually exclusive, the intersection is 0, and this formula can be applied anyway. So we can say that the number of elements in the union is equal to the number of elements in A plus the number of elements in B minus the intersection of A and B. We can also say that the probability of A union B is equal to the probability of A plus the probability of B minus the intersection of the probability of A and B. Okay, so these are the formulas that you can use no matter what. You don't have to have mutually exclusive sets for these to work. They work all the time. Okay, so these are the ones that I would use if I were you. So the next problem says a pair of dice is thrown. What's the probability that the dice shows doubles or a sum over 7? Okay, well, let's find the probability of the dice showing doubles. And let's also find the probability of a sum over 7. So if I want to get doubles, that's going to be either 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. So that's going to be 6 out of 36 possibilities. So if I'm going to get a sum over 7, if I look at my dice chart here, I can see that that's going to be 15 over 36. So there's 15 outcomes that have a sum over 7 out of the 36 total possible outcomes. So now I can use this formula, but I need to think about, are these sets mutually exclusive? Do they have anything in common? So I personally like to start with the smaller set. So I know that the smaller set in this case is going to be my doubles. And I like to think about, is there anything in that set of doubles that would be a sum over 7? And the answer is yes. So if I look at 4 and 4, that would give me a sum of 8. If I look at 5 and 5, that's a sum of 10. And if I look at 6 and 6, that's a sum of 12. So I know there's 3 elements that are going to give me something that they have in common. So there's 3 elements in common between those sets. So that means that my intersection between these 2 sets is going to be 3 out of 36. So if I apply this formula here, I can say that the union is going to be 6 out of 36 plus 15 out of 36 minus 3 out of 36. So 6 plus 15, that gives me 21, minus 3, that gives me 18 out of 36, which simplifies down to 1/2. But you can just leave it like this since we're talking about fractions, and sometimes it's nice to know that it was out of 36 possible outcomes. Okay, the next question, we want to talk about complementary events. So what does something mean to be complementary? Well, you might have already talked about complementary events in geometry, and complementary angles in geometry and complementary events are pretty similar. With complementary angles, you know that 2 angles add up to 90. Okay, so you can take 90 minus 1 angle to find the other angle. Well, complementary events are the same way, except our complementary events, the probabilities add up to 100%. So basically, if you know one event, then you know you can take 100% minus the probability of that event to get the other event, the complementary of the other event. Okay, so 2 dice are tossed. Find the probability of each event. The probability that the sum is 4. So if you look at your dice chart here, the probability that the sum is 4, we've got 3 possible ways that we could get a sum of 4. So that probability of having a sum of 4 is going to be 3 out of 36. So real quick, if I want to figure out the probability of the complement, which would be the sum is not 4, okay, so the sum's anything other than 4, I know that that's just going to be 36 out of 36 minus 3 out of 36. So that's going to give me 33 out of 36. Okay. And let's see. In order for something to be called complementary, it's important to remember that they have to be mutually exclusive, meaning that they can't have anything in common, and also their union has to be the entire sample space, meaning that all solutions in the sample space must be represented by those two sets, which is why the probability of the sum being 4 and the probability of the sum being anything but 4 would be complementary events, because if I put those together, I would get the entire sample space, and also I know that these sets don't have anything in common. All right.